All right, guys, we're going to look at curve of best fit. So we talked about a line of best fit shows us how to predict the predictions for a linear equation. And remember, that's where we did that y1 approximate mx1 plus b. We put it in Desmos, and Desmos told us what the m approximately was and what b approximately was as well. Okay, so now we're going to look at data if it's not linear, if it's more of a curve. So, how to create a quadratic equation. Okay, now one thing to keep in mind, just like with linear, we need to identify that as y1 and x1 because when we're doing our table. Okay, so if we were to put this table into Desmos and we were to type in this quadratic equation into Desmos. Desmos is going to tell us instantly what that A, B, and C is. Okay. And so we would see that because this is negative 0.6, our A value, we would replace it with negative 0.6. Our B value would be 0.5, and our C value would be 2.2. Okay. So we could identify what equation this would be based on the table or the set of values that we were given. Okay, so now we are being tasked with, is the data representing a quadratic? Does it have a curve to the data? Or is it linear? Is it creating a line? Okay, the only way to do this is by using our Desmos. So we're going to create a table. So if I were to bring over my Desmos and I were to create a table and I were to put my data in there, -4, 8, -1, 4, 3, 5, 7, and 11. Okay, so I have my data in there. Now I'm going to come down here and I'm going to put my equation in for my quadratic equation. I'm going to say y1 approximate ax1 squared plus bx1 plus c. Now notice a couple things. Notice you can see my green data points. There's all 4 of them. 1, 2, 3, 4. They're creating that curve. Okay, so we can say that, is my data linear or quadratic? It is quadratic, and I can determine my equation by using my data points. So I know it is going to be y equals, and we're going to say 0.185x squared minus 0.263x plus 3.86, because that's what my A, B, and C are on Desmos. Okay. Then it says in our notes, use the equation or table feature of the calculator to find the following. If x is -8, what is y? Okay, so we're going to go into Desmos and we're going to say 0.185 a, well, we're going to use d because we don't have a value for d yet, squared minus 0.263d plus 3.86. And we're going to identify my d point as, on my notes, it wants -8. So we're going to do -8 first. And it says it's going to equal 17.804. Then it asks, okay, well, what if x is 15? So let's change our d value to 15. It's now giving us an answer of 41.54. Now it wants to know, well, what if it's 0, x is 0? Y is going to be 3.86. Okay, so let's go to the next page. It says for me to determine whether each set of data fits a linear model, quadratic model, or neither. It could happen. Remember, linear is going to be a line. Quadratic is going to be a curve. All right, so let's pull out my Desmos again. Let's clear out these two rows. I'm going to leave my equation in, but I'm just going to change my points. Okay, so I'm going to change this to be, let's go back up here, negative 5, 33, 2, 13, negative 1, negative 3, 0, negative 2, 7, 42, 3, 43, and negative 2, 0. All right, so let's see. All right, so let's zoom out a little bit. So notice my points. See how they're kind of, can't really show you all of them. It's kind of weird. But notice how they're not really curved and they're not really linear. So this would be a neither situation. Okay, it's not creating, you can look on Desmos, it's not creating a curve. It's not creating a line. Okay, they're not making that nice shape. Okay, all right, so let's put our second set of data points in. So we have 5, 4, negative 3, negative 5, 10, 7, 8, 7, 0, negative 1, negative 4, negative 3. I gotta get rid of this last set. All right, so now if you notice, you've got your 6 points, but they're not creating a curve, though they could create a line of best fit. So this one would be more linear than quadratic. It's creating that line. Okay? All right, let's go to our next question. It says, Amy recorded the distance and height of a basketball when shooting a free throw. So we have her data points, and it says find the quadratic form equation of the table. So let's come over here to our Desmos. I'm going to shrink up my Desmos just a little bit so I can see this. And we're going to put in our data points. So we're going to say 0, 4, 2, 8.4, 6, 12.1, 9, 14.2, 12, 13.2, 13, 10.5, and 15, 9.8. All right, so let's look at our data. We can really see that it's making that curved feature. But notice it's giving us our values. It's giving us A equals, we're going to say that's negative 0.12. We're going to say B is 2.11, and we're going to say C is 4.22. So now let's write our quadratic equation. So we're going to say y equals negative 0.12x squared plus 2.11x plus 4.22. Then it says predict the height of the ball when it is 4 feet away from Amy. So that means I'm going to use this quadratic equation that I've created to predict. So I'm going to say negative 0.12. I'm going to go ahead and we're going to use d again squared plus 2.11d plus 4.22. And of course, we're going to say d is 4. And it predicts that it's going to be approximately 10.74 feet away from Amy. Okay? So now let's do the next question. A person's electric bill is a function of the temperature. At low or high temperatures, the amount of electricity used increases, and so does the monthly bill. So again, it's asking us to create or find that quadratic equation. So let's go back to Desmos. I'm going to go back to my table and I'm going to re-put in my information. So I have 32, 265, 41, 173, 50, 100, 59, 91, 69, 85, 77, 100, 85, 185, and 90, 285. All right, so I have my information. I can't see anything on my graph. Well, duh, my points are too big. So let's change our functions. So I kind of zoomed out some and I can see 1, 2, 3, 4, 5, 6 of my points. Oh, there's 7. Oh, there's my 8th one. Okay, so I can see them all. And they're making that nice curve. So if I go back over here, I can see, let's come down here on my notes, A equals 0.23, B equals negative 28.79, and C equals 954.21. So if I were to write that out, I would say y equals 0.23 x squared minus 28.79x plus 954.21. And then it wants to know the prediction for the total bill when the temperature is 80 degrees. So let's come down here. We're going to say 0.23d squared minus 28.79d plus 954.21. And of course, we're going to say D is going to be 80 degrees. Oh, that was wrong. It should have been a 9, not a 0. There we go. All right, so our bill is going to be 123.01. All right, so let's answer our question. How do we know that the better model to use is a quadratic fit rather than a linear fit? So if we think about this one, when we think about temperature, okay, think about temperatures. When it's a nice weather, sometimes we will turn off our AC or turn off the heat. That there's really nothing in our house we need to have running. So if you notice that when the temperature is nice, notice that 59 to 69, that's when the weather's nice, that we're not using a lot of power. But when it's really cold, we want that heat on. When it's really hot, we want that AC on. Okay? So we know quadratic is better for this because the electricity will run during very cold or very hot temperatures. And that's all it is to curve of best fit. Again, remembering that quadratic equation.